Okay, let's go, guys. So, question one, you guys on your assignment have letters. This one is just cars. So, you just have to treat each car like a letter. Okay, so question 1B is similar to what you guys have. So, what you want to do is count how many letters or count how many cars there are. In this case, we have 7 cars. So, I'm going to put 7 spots. Okay, so anything that has to go together, you're gonna group them at the beginning. So if there's 2 cars or 3 cars that would have to go together, I'd put a square around them to keep them together. So for example, it says how many ways can you park them so that the pickup truck is next to the hybrid truck. So these two things have to be together, so that consists of 2 spots. If there was 3 letters that had to stay together, you would kind of put a circle around 3 spot just to kind of keep that in your head that those are separate. So what you need to do is when you're looking at this unit of permutation combination, this is a permutation question because order matters. When you put something in a spot, it looks different if you rearrange them. So what you want to always put in the spots is how many choices you have for that spot. So for example, we know that these 2 first spots have to be the pickup truck / the hybrid car, right? So for the first spot, I have 2 choices because there's 2 cars that could potentially go in there, either the pickup truck or the hybrid truck. Now, let's say we pick the hybrid or the pickup truck to go in that first spot. That means we have 1 more choice left for the next spot. So when it comes to letters or items or people, once you put something into a spot, you have 1 less for the next spot. Okay, you've already used someone in that spot, so you don't have as many options. Now you're going to rearrange the other cars. These are the other cars. Okay, so the other cars, there are 5 cars left to rearrange. So we would say that there's 5 choices for this spot. And then once you place a number into a spot, you have 1 less for the next spot, and then so on. So these are the remaining cars just being placed, okay? So whenever we count down from a number all the way to 1, those are represented by factorial. So 2 times 1 is the same as saying 2 factorial. And then 5 times 4 times 3 times 2 times 1 is the same as saying 5 factorial. Okay, so far we have that. Now there's one other thing you have to consider for question number 1 on your assignment. The hybrid car and the pickup truck don't have to be in those first 2 spots. They can be anywhere within or in between the other cars as long as they are together. That's the only rule they're giving us. And in your assignment, it even tells us that they don't have to be arranged in that certain spot. They can be anywhere. So what you need to do finally to get the full correct answer is you have to put the pickup truck and the hybrid into spots. So where they are right now is spot number 1. So that's where the arrow I just drew is. And then they could be between these 2 cars, 2 spots, 3 spots, 4 spots, 5 spots, and finally they could have been at the end. So it's always going to be 1 more spot than there are remaining items. So if there's 5 cars remaining, that means there's 6 spots because it's all the in-between areas. So what you want to do with this answer of 2 factorial times 5 factorial is you want to multiply by how many spots, meaning those purple arrows, that they can go into. So there's 6 spots that they could have gone into. Now, you could also calculate this as 6 factorial. Because if you guys look, there's a 6, then it's 5, 4, 3, 2, 1. So as long as it counts down from a number, you can write it as a factorial if it counts down to 1. So our final answer, if we put this into our calculator, it'll be 2 factorial times 6 factorial to get the final answer. So I'll show you where that button is in your calculator if you're unsure where to find all these like NPRs and all these buttons. So if you go to your calculator, you would press the number first. So I would press 2, then math. I go to the right, I scroll to the right until it says probability at the top. So if you guys see, it's PROB at the very top. So I'm going to keep moving my cursor until I get to probability. And then as you can see, these are all the functions you would need for this unit. We have NPR, number 2, we have NCR, and then we have factorial is number 4. So you press number 4, and then you should get this exclamation mark. So that just means that you're going 2, then 1, and that's the same thing as 2, right? So I'll just put in the other numbers as well. So we have 2 factorial multiplied by 6 factorial. So this is just a nice quick way of calculating it without going 6 times 5 times 4 times 3 times 2 times 1, etc. So the answer should be 1440. I know it's sometimes hard. I can't even zoom in here, which is the crappy part about this calculator. So it's 1440, your answer. 1440. And I'll just give you a little reminder that I went to math, I went to probability, and then I went to number 4 to get these exclamation marks. Okay, so math probability is where you're going to find all those little keys that you need. Okay, so that's how you would do question number 1, but you're just looking at letters instead of cars. That's the only difference, but same idea. Okay. Question number 2, you guys have people for this one, but I have cards, okay? So it's still gonna be, again, the same kind of thing. You just have to look at what do they want versus what do you want, okay? So question number 2, what you always wanna ask yourself is the question a permutation or is it a combination? So in this previous one, it was a permutation because order mattered. When you arrange something in slots or in a row or in a lineup, order does matter. When you are selecting cards from a deck or you're selecting like a group of 5 girls, 5 boys, we're assuming they're doing the same job, so order does not matter. So we use something called combination. So we use NCR to represent that. So order does not matter when it comes to selecting 5 cards from a deck of cards, right? As long as you have those 5 cards, it doesn't mean you don't have to have like this king's first and then jack's second. It doesn't matter there, okay? So for the first question, it says, how many ways can you select 5 cards? So N means how many choices do you have to choose from? And R always means how many spots are you putting them into? Well, N in our case, there's 52 cards to choose from. And then our R represents how many cards we actually want. Well, I want to select 5 cards. So it's 52, choose 5. This is actually quite a large number. So in order to put this into your calculator, you're going to go into you're going to press always the N button first. So you're going to go 52. Then I'm going to go math to probability. And then I'm going to choose number 3, which is NCR. And then it's N, choose, then we put 5. Okay, so you're always putting your N first. Then you're using that math probability number 3 button, I believe. And then it's the R button right after it. Okay. So I get a large number. So it is 2,598,960. So that's my answer for the first one. Question B, it says, in how many ways can you select 5 cards if 3 of them are hearts? So something to keep in mind is, especially with your question, it tells you how many people they want in a committee. So always keep that in the back of your mind. Here, it says that we're selecting 5 cards. So keep that in mind. So always make sure your R's add up to how many cards you're selecting. So if you have 5 cards, your R's should add up to 5. So we want 3 of them to be hearts. So we start this question by saying, how many hearts do we have to choose from? So how many choices do we have? In a deck of cards, there are 13 hearts, and we want to choose 3 of them for our deck. So as you can see, there's my R value. I only now have in my hands 3 cards, okay? So that means I need 2 more cards. So I have to have some like missing and choose 2. Right? So I always need to make sure that that R value makes sense, that it adds up to how many cards I actually want to select or how many people I want to select. So we already chose 3 hearts. That means that the 2 cards are going to be non-hearts. So what you want to do in on like the side is you want to say, well, there's 52 cards in a deck. You are subtracting 13 cards from that. And you'll get 39 cards that are not hearts that you're selecting from. So from 13 hearts, you're selecting 3. And from 39 non-hearts, you're selecting 2, and that's going to give you your total, which is 5 cards that you need. Okay, so if you put that into your calculator, you would do like one at a time or write it exactly how you see it. So I'll show you how I put it in my calculator. I'm going, what was it, 13 math, probability, 3, and I'm choosing 3 of them. Multiply that answer by 39 math, choose, and I want 2 of them. Okay, so let's say for your question, as you can see, this calculator is not reading it properly, but the answer should be, if you do it in your own calculator, 211,926. Okay, so if they're asking for this many girls, this many boys, you would do the same thing. You'd say from this many girls, I'm selecting 2, or from this many boys, I'm selecting 3. So it just depends on how they word it or what they want in the question. The last question, you have to look for keywords. So our keyword that you want to focus on is this word at least, or if you see at most. Those are words that tell you that you're going to have cases. You're not just going to have one line. You're going to have multiple kind of options that could be your answer. So for example, I want at least one of them to be black. So 1 black. At least means minimum. Okay, so I want minimum 1 black, which means that one case could be where I have 1 black. I could have 2 blacks. I could have case 3, 3 blacks. I'm going to add another page here. Okay, I could have case 4 being 4 blacks. And finally, the maximum cards you can still have is 5 cards. So my 5th case is where I have 5 blacks in my hand. Okay, so you kind of have to go through each option saying, well, how many blacks are there in the deck? Half the deck is always black, half the deck is red. So you can look that information up or even ask me if you're not sure what a deck of card looks like, but you don't have that kind of question. You have like a people one. So there are 26 black cards and you're choosing 1. Okay, so that's my 1 black card. Now I need 5 cards in my hand, and so far I only have 1 selected. Okay, so that means from the non-blacks, and the opposite of black is actually red. So from 26 red cards, I'm going to choose 4 more. So I'm going to have 1 black card in my hand and 4 red. And then you're going to calculate that. So that's going to be your first case. Your second case, you're saying from 26 black cards, I'm choosing now 2 of them. And then from 26 red cards, I want 3 cards. As you can see, my R values are always going to add up to how many people or how many cards I need in my hand. So if you need like a committee of 5 people, then you should make sure your R values add up to 5. Same for the next question. You're going to say 26 black cards, and I'm choosing 3. 26 red, choose 2. 26 black cards, you're choosing 4 of them. And then from 26 red, you're choosing only 1 to make that 5, right? So as you can see, those add up to 5. All of them add up to 5. That's how you're kind of checking that you're on the right track. From 26 black cards, you're choosing all 5 of them to be black, right? So you don't have to do anything with red if you don't want to. You could put 26, choose 0, but that actually equals 1, so it doesn't affect your answer. So then what you would do is you would calculate all these answers. So this one is 388,700. So I would just put that into my calculator and get these answers. Now, once you're done this step, now what you're going to do to get your final answer is you're going to add up all these answers, okay? So between the cases, you add because you're saying I could have 1 or 2 or 3 or 4 or 5. And between that, you always add. So the addition of these numbers would be 2,533,180. Now I want to show you a faster procedure. So there is a quicker way to do this question and still get the exact same answer. So if you want to save yourself some time with this question, what you could do is figure out the total and then subtract where there are no black cards. And that will also give you the same answer. The reason being, if I have no black cards and I subtract it from all the potential totals of cards, then I'm going to get every group of cards that has black in them. Okay, so if I take off the black cards, I get everything else that does have a black card, which is all these cases here. So my total comes from the question A. Remember how we did, there was 52 cards in the deck and we're choosing 5 of them. That's the total kind of ways that you can select 5 cards with no rules. And then we're saying how many sets are there that have no black cards? Well, if there's no black cards, that means that all of them have to be red. So from 26 red cards, I'm choosing 5 of them to be my set of 5. And then all you'll do is you'll put this into your calculator. You can do one at a time if you want to, or you can actually just do it in one step and write it exactly how you see it. 52, choose 5. We already had that answer. So I'm just going to write it down. And then we already had the 26, choose 5, which was this. If you subtract these two numbers, you're going to get 2,533,180. So you're going to see that these two answers are going to be identical. So as you can see, this is the fast way. This is kind of doing something called an indirect method. And this is doing the direct method where you're doing exactly what they're asking for. Okay. So does that make sense for you guys? How are you guys doing so far? So that's question number 2. Any issues, guys? Good. How are the rest of you guys doing? Okay. Good, Eduardo. Perfect. Liam's good. Okay. Good. Awesome. Almost there, guys. Our next question number 3. So I'm going to do B with you guys. So that kind of looks similar. Yours, I think in your assignment gets to like a quadratic. So that's the only difference. So if you did want to see what I did afterwards, I can do A as well really quickly. So I'll kind of go B slowly and then A I can do really quickly just to show you like what it becomes. So what you want to do is you want to use your formula sheet. There's 2 formulas that are given on your formula sheet and one of them looks like this. N choose R is the same as saying n factorial over n minus r factorial r factorial. And then NPR is equal to n factorial over n minus r factorial. So those are 2 formulas that are given on your formula sheet. So you just want to now use your n and r and replace it into that factorial kind of side. So n choose 3. N choose 3 would be like saying n factorial over n minus r is being replaced with 3. So wherever you're seeing r, you're replacing that with a 3. So that is the left side of my equation. Now we're going to go to the right side. The right side has a 4 multiplied by NPR. So we're going to multiply it by n factorial. So I'm looking at the bottom, this one right here now. So n factorial over n minus, now r is 2 factorial. And then there's no other place to put 2. So that's the simpler kind of version. So what you want to do is, usually I like to work with these factorial numbers first. So I'm going to work with these 2 guys first and try to put them together if possible, just to get that out of the way. So in your calculator, you would calculate what 3 factorial is equal to. So 3 factorial is just the same as saying 3 times 2 times 1, or you can use the button in your calculator. You'd put 3, math, go to the right, probability, number 4. So that's just 6. So that's just, it's easier to just calculate that by hand, I find. So far we have n factorial over n minus 3 factorial times 6 equals 4 times n factorial over n minus 2 factorial. So what I'm going to do is I'm going to join that 6 with the 4 by multiplying both sides by this 6. So I'm going to multiply the top by 6 and I'm going to multiply the right side by 6. So that's going to cross off that division of 6. And that's going to leave me with n factorial over n minus 3 factorial, which is equal to 24 times n factorial over n minus 2 factorial. So all I did was I brought that 6 to the other side. That's it. Now, this is where you want to look at which level is higher. So you want to look at the fractions, meaning these guys right here, and ask yourself, in each one separately, which is bigger? Is the top bigger or is the bottom bigger? Well, n is bigger than n minus 3. For example, if you have n as 5 and you have 5 minus 3, well, 5 is going to be bigger than 2 factorial, right? So this is bigger for that one, and then this is also bigger in comparison to n minus 2, okay? So always start with the bigger one. And what you want to do is you want to count down from that. So after n, if you were to count down, it would be n minus 1. And then you would keep going. After n minus 1, now you're subtracting another one. So n minus 2. And then n minus 3. You're going to stop where you see the exact same factor in your denominator. This is your denominator, right? You guys see how there's an n minus 3 factorial? That's when you have to stop, okay? So I'm stopping when I see the exact same factor at the top and the bottom. The bottom is not changing. So the reason we do that is now these two guys can cross off with their factorial. So now it doesn't continue on forever, because that's what factorials do. They continue all the way down to 1, and we don't know where that is because we don't know what n is. So we're getting rid of those factorials by counting down until we can cross off the same factors, top and bottom. Now you do the same thing on the right side. After n comes n minus 1. After n minus 1 comes n minus 2. And you stop there because I have the exact same factor at the bottom. Now you're going to cross off the n minus 2 and the n minus 2, as you can see. So what you're left with on the left side is n and n minus 1, n minus 2 after you crossed off those n minus 3s. And on the right side, you have 24, n and n minus 1. What's nice about this is if you see the exact same factors on both sides of the equal sign, they cancel each other off. For example, n and n cross each other off, n minus 1 crosses itself off. So what you're left with is n minus 2 equals 24. Now all you have to do is add 2 to bring and solve for n. N is equal to 26. So that would be my final answer. Now I'm going to go through A just pretty speedy because I just want to show you what yours will probably get to and what to do after that. So that's how you do. Yours will probably be up pretty much the same up to here, and then it kind of goes differently from there because it doesn't become like a linear equation. It just becomes a quadratic for yours, I'm pretty sure. I'm like 90% sure. Don't like quote me on it. I haven't done it yet. I just like picked out that question. I was like, I think that's quadratic. So for A, remember how we're using n over n minus 2 factorial, 2 factorial. And that's equal to 28. So this 2 I'm going to bring to the other side, and that's like saying 2. Okay, so 2 factorial is just multiplying 28 by 2, so it's going to be n factorial over n minus 2 factorial, which is 56, because 28 times 2 is 56. And then just like in the previous case, I'm going to count down n minus 1, n minus 2, stop there because I have the exact same factor at the top and the bottom. So those will cross each other off. And now you're left with n multiplied by n minus 1 equals 56. Okay, so once you have that, now you want to distribute that n into the brackets. Now, if you have a 2 by 2, you're going to do FOIL, right? So it's up to you if you have a single value multiplying or if you have distribution. So it's going to be n squared minus 1n and then minus 56, which is equal to 0. Okay, so as you can see, I distributed and I brought that 56 to the left side of the equation and I made it equal to 0. So now you want to factor this. So you want to look for two numbers that multiply to 56 and add up to -1n. So I found that they were n minus 8 and n plus 7 equals 0. So once you get a quadratic, factor it and then solve for the factors. So one value is 8, one is -7. Now you want to pick the one that doesn't make the factorial or doesn't make the n value negative. So this one doesn't exist because if you try to calculate -7, choose 2 from my previous question, like if you're checking, you'll see that it's an error. You can't put in, and you can't have a negative factorial ever because it always is positive going down to 1. So you can't start from -7 and go down to 1 by subtracting ones. So that will never happen. So the only answer that exists will be the 8. So make sure you pick the right, the answer that makes sense for the question, okay? So check your answer is what I'm saying for that one. Any questions about that? So all it is just using your formula sheet, replacing these into the left side, into the right side, and then just trying to solve for your n. Okay, so as long as you kind of pick the higher level and count down, you should be able to cross off those factorials. Are we good? Good for question number 3, guys? I'm not frozen, I'm just waiting. When the number is on the same side as factorial, what do you do? Same side as factorial. Same side as the factorial. What do you mean? Like in 4? Which number 4? Let me see. Are you talking about the one in like in the assignment that I gave you? Like if 4 was on the same side as 3 factorial. Oh, I see what you're saying. Okay. So you're saying what if, okay, I get what you're saying. Here, let me add a page. I was trying to see where this 3 factorial was, all that stuff. Okay, so you're saying, what if I had n factorial over n minus 3 factorial, and then I had 3 factorial, and then there was a 4 here, and then that here. Is that what you're asking for? Pretty much the same. What all you're doing is you're just putting them together. You're just going to get then a decimal, right? So in your calculator, you would just go 4 divided by 3 factorial, which is 6. And then you'd get like a fraction of like, what was it, 2 over 3 or something, right? So you would just write n factorial, n minus 3 factorial. And what I usually do is I kind of like just stick it there. So I'm just going to stick it as 2 over 3, n factorial over n minus 3 factorial, and then work with that. And then once you get to a certain point, I just want to show you if you did get to this. So this is an interesting case. Like it's not harder, it's just, so you would still do that countdown thing, just like previously, right? So you always count down from the higher one, cross these guys off. You're still having that 2 over 3. The right side, same thing, you count down and you cross off. So after n comes n minus 1, and then it's n minus 2, and then it's n minus 3. And then n minus 3 would cross off from the top and bottom. The 2's will cross off. The n minus 1 will cross off. Oh, am I doing too much? I think I wrote that wrong. That's why. Yeah. That should be a 2. I was wondering why it was all crossing off, because they're the same. Duh. Okay, so it's n minus 1, n minus 2. The n minus 2s will cross each other off, leaving us with the n's crossing off and the n minus 1's crossing off. And then we still have the n minus 2 left over from the left side, multiplied by 2 over 3, which is equal to now 1. Because when you divide something, the entire thing on the right side, you're going to have 1 left over. Okay, so it doesn't just become 0, there's still like a 1. Now this is where it's interesting. So all you have to do now is, usually I would just multiply everything by 3, the left side and the right side, because that will then get rid of the fraction. So you don't really prefer to work with fractions. So I would then multiply both sides by 3. So that way I have n minus 2 multiplied by 2 equals 3. And then I would distribute. So 2n equals 7, and then I would divide by 2, and I would get that n equals 7 over 2. Now, this was a made-up question, which is why you're getting a fraction, but you know you're on the right track if you're getting a whole number. You shouldn't get decimal values when it comes to n. So you should only get like integers, okay? Now, if you get a positive integer, that's most likely your answer, but you should always substitute it back in to see if left side equals right side, right? So usually the negative integer isn't an answer. So if you plug it in, it'll give you an error. So that's why you want to check and cross off the answer that doesn't make sense. Does that answer your question, Wilfred? Yep. Or yet? Okay. Okay, our last question, guys. So this is the most common kind of question, and I'm going to give you 2 examples of that one. Okay, so there's only one in your assignment, but I wanted to kind of work through both of these just to show you and make you confident with this, okay? So what you want to use for this is a formula on your formula sheet that looks like this. Tk plus 1 equals NC, I think it's NCK. Then it's x to the power of n minus k and y to the power of k. Okay, now when you're looking at this first coefficient or first term should always be your x value, and then including the sign, the second term should always be your y value. And then your power should always be your n. So you want to use those as hints on how to start this question. So as you can see, k is not given. We don't know what k is. So our process for the first part of this question is trying to figure out what k is. And once we figure out what k is, then we can go back and actually solve for the constant term. So we're going to leave k blank. And that's what you're going to do for yours as well. N is, in my case, 12. It's the exponent on your binomial. So it's going to be 12 choose k. Your x value is going to be replaced with x squared. And then we have 12 minus k. And instead of y, we're going to go negative 2 over x to the power of k. Okay, so that's all I'm doing is I'm replacing what my x, my y, and my n value are from just that binomial with the power, okay? So far, this is what I have. My next step is now to just pull out the values of x. Anything that has x, I'm going to pull that out and kind of ignore everything else around it. So this is kind of like a little trick to be able to find out the constant term. Because when it comes to a constant term, that means x has to be to the power of 0, because that's the only way that it will disappear and it'll give you no variables. So that's what a constant term is no variables. So we need to figure out what will make x to the power of 0 occur. So I'm going to look at just the x2, 12 minus k part, and then I'm going to look at this part right here. But in order to make it the same level as everything else, I have to flip that over x value. So it's going to become x to the negative k. So as you can see, whenever you bring something from the bottom level of a fraction to the top, it changes your power from positive to negative. So the k pertains to it. So all I did was I flipped it and I made it a negative k. So that's kind of a hint to you, is watch that you do that. And then what you're going to do is make this equal to x to the power of 0, because if you can solve for the k that makes that happen, then that's what you're going to use for the rest of the question, and you're going to go back and use that from the beginning. So you're going to need to remember your exponent laws, where here I'm going to distribute the 2 because it's going to multiply the 2 with the 12 minus k. So it's going to be x 24 minus 2k, and then multiplied by x to the power of negative k. So that's x to the power of 0. Whenever you have two x's multiplying, you add their powers. So you're going to simplify it and add these two together. So 2 bases becomes a single base. So you're just going to write then minus k at the top, because it's like plus minus k. And so that simplifies it to a single power on each side, or a single base and power on each side. So now we're just going to simplify the k's together. So it's going to be x 24 minus 3k equals x to the power of 0. And then now, when you have the exact same bases, this is kind of from your exponent unit. What happened to the 2 in the numerator? Oh, the 2 in my numerator. Oh, remember how I said that only the values with x, you ignore everything else. This doesn't have a value of x. That's just a coefficient, okay? That's like saying negative 2x to the negative k. It's a number in front. It's not actually x, okay? So you're only looking at the values of x just for now, okay? So we don't care about the other ones just for this step, but we will use it for the next step, okay? So you'll see what I mean. So in this example right here, now, whenever you have the same bases on each side, you can ignore them and make 24 minus 3k equal to 0 and solve for k, because the whole point of this is finding out what k is. If we can find out what k becomes, or what it is to make x to the power of 0, then that will help us go back and solve for the actual constant term, okay? And then we'll use that negative 2, that coefficient. So all I have to do is solve for k by bringing the negative 3k to the other side of the equation and dividing by 3. So k is equal to then 8. So now that I have k is equal to 8, now you're going to go back to this step right here and replace wherever you see a k, you're going to replace an 8 in there, because the whole point is to get that constant term, okay? So you're going to go t 8 plus 1, so we're actually looking at term 9 here. So term 9. And then you're going to, in your calculator, you're going to put 12, choose k. So for the people just joining me, you're going to put 12 first. You're going to go to math, probability. Number 3 will be n choose r. So that's how you get that. So math, probability, number 3. So it's n choose r, and then you're pressing, I think it was 8, right? Yeah. So I get 495 from 12 choose 8. 495. And then now I have x to the power of 2, and then 12 minus 8, which is 4. Okay, so do you see how I'm placing that k value of 8 and then going 12 minus 8? So that's how I got that 4 there. And then now, do you see how I still have this negative 2 over x to the power of 8, because our k is 8. So all I need to do is put these guys together and then distribute the 8 into the brackets. And then what I'm going to do is join all the coefficients together at the very end. So far I have 495. I have now x to the power of 8. And then negative 2 in your calculator to the power of 8 is going to become a positive number, because negatives to the power of 8 will become 256 over x to the power of 8. So I can distribute that 8 to the top, and that includes the sign. So keep that in mind. So it goes to the negative, the 2, and the 8. And so this is what I have now. So remember, all that work before was just to find out what our k value was that would make these guys cross each other off. So as you can see, I have x to the power of 8 in the numerator and x to the power of 8 in the denominator. So they cancel each other off, leaving us with 495 multiplied by 256. So if you put that into your calculator, that's what term 9 is, 126,720. So that's our final answer. So you shouldn't have any variables because the question is saying what is the constant term, okay? So that is the final answer for question 4A that I took from your textbook. Now I'm going to do question 4B just to show you that it's the same, just for extra practice here. So this is the next one, B. Y minus 1 over y squared over, to the power of 12. So first label what everything is. Well, x will be your y, and y will be replaced with negative 1 over y squared, and n will be replaced with 12. So you look at that binomial, and remember the first is always your x, including the sign is always, the second term is your y, and this is always your n. So label that so that way you put stuff in the right spot. And then you're using that formula. T, k plus 1 equals n choose k, x to the power of n minus k, y to the power of k. So here, again, just like in the previous one, we don't know what k is. We're trying to solve for k. Once we find k, we go back to this, and then we replace it all. So tk plus 1 equals n is 12, x is being replaced with y, and then 12 minus k, and then y is being replaced with negative 1 over y squared, and then your k value is unknown. Okay, so that's what I'm doing so far to replace it. So just like in the previous one, I kind of took out all the variables of x and I worked with those because you're trying to find out when x was to the power of 0. Now you're trying to find when y is to the power of 0 so that you can find out the constant. Okay, so our goal is to look at just the y's and make it equal to y0. So I see that this is a y value. And then remember, this part is a y value, nothing else. Okay, there's no other y's. So we're going to write that out. Y to the power of 12 minus k multiplied by y to the negative 2. Do you see how I'm flipping it? And it's becoming, instead of power of 2, it's becoming negative 2. So that's why it's on the same numerator level. And then we have this k power outside of the bracket. Okay. And so that's going to have to equal y0 in the end. So that's my goal in part all of question 4. Okay. So now it's just about putting these guys together by multiplying. So we have y to the power of negative 2k equals y to the 0. Now, remember how whenever you multiply two bases that are the same, you write it as one base and then you add the powers. So I'm adding negative 2k. So it doesn't change the sign. And then once you get the exact same bases on each side, cross them off. You just have to solve for where 12 minus 3k equals 0. Bring this to the other side. So 12 equals positive 3k, and divide both sides by 3. K is equal to 4. So once you have k as 4, remember how in the previous one, just like that, you want to go back to this step and now replace everywhere you see a k with 4 and solve for what that term actually is just by simplifying. So we're looking at term 4 plus 1, which is meaning that we're looking at term 5. Which means, and then 12 choose 4, we're multiplying by y to the power of 12 minus 4, and then negative 1 over y squared to the power of 4. So 12, where's my button there? Oh, I'll just use my regular calculator. 12 choose 4. You're putting that into your calculator. Remember the buttons that to find this, you would go math, probability, and then it's number, I forgot, 3. Yes. Okay, so math probability number 3. Okay, so you should be getting 495. So once you have that, now you're going y to the power of 8, because 12 minus 4 is 8. And then here we have -1. We can write that as it is. And then we can write over. Actually, I'm going to distribute. I need to distribute that properly. So I'll just show you that. So this one I'm going to distribute, remember, to the 1, to the sign, and then to the bottom. So that 4 goes to everything within the brackets. So a negative to the power of 4 is going to become positive. 1 to the power of 4 is going to stay as 1. And y squared to the power of 4 is going to become y to the power of 8 now, because the 4 and the 2, the powers multiply to each other. So what you should notice is that these two guys cross each other off, leaving us with just 495 multiplied by 1. And so our answer is 495, and that's the constant that is in term 5. So that is how you do those guys. Are there any questions? So if you want to stick on, I can help you with your previous assignments, guys. I can help you with, if you miss like the first part, if you want me to go over that, I can definitely do that for you guys. So if you're good and you feel confident, good luck with your last assignment. Good luck with your future courses and whatever path that may take you. So I hope to see most of you at graduation. So I know there's a few of you that won't be there because you're not in grade 12. So that'll be a next year kind of party for you. But anyway, in the meantime, get your assignments done, guys. I really, really, really want you to enjoy next week. So there's lots of plans for next week, and I want you guys celebrating. I want you guys celebrating instead of doing all this work. So if I can help, today is the day. Today I am free to like go on Google Meets. I can get you guys finishing those assignments and then handing them in so that you can move on to hopefully celebrating next week instead of doing and sitting on assignments, okay? Yeah. Anyway, good luck, guys, and then stick on here if you need help. So just stay on here if you want me to, because a few of you came in later. If you want me to go back and do questions 1 to 3, then I can do that for you. So just let me know in the comments what you need from me, and I will help you get that done. Oh, you made Sarah leave. You made fun of her. No, I'm just kidding. Sarah's good. She's good. She knows what she's doing. Any questions, guys? Questions 1, 2, 3. So the people that missed question 1, do you want me to go through that again? Anything from trig? I don't know what that means. Is that like a laughing face with a tongue? Like, I don't even know. Looks like lips, like sideways lips. You want to see number 3? Do you want me to do another one like this? I can try to find something similar in the textbook. Let me see if I can find another one. I can make one up too. Oh, you just need to see it? Okay. Let me stop the recording here so it doesn't